Hello, I'm going to go over a problem from the Stoichiometry practice worksheet called Grams to Grams, and let's take a look. So it wants to know how many grams of hydrogen are necessary to react completely with 50 grams of nitrogen in the above reaction. So in order to solve this problem, we can take this diagram that shows us what kind of math we need to do and tailor it just a little bit. It can also mean grams of substance A to moles of substance A. And it can also mean moles of substance B, grams of substance B. This means that you don't have to only go from reactant to product. You can go from reactant to reactant. So let's define what A and B are in this question. In this question, it says how many grams of hydrogen are necessary. So we're trying to find that. Let's call substance B in this problem hydrogen. The reactant hydrogen. Let's call substance A the reactant nitrogen, because that's what we know at the beginning. So let's put the start and end on our diagram here. We are starting with 50 grams of nitrogen. So we said nitrogen is substance A and grams are right here, so we're going to start here. And we want to know how many grams of hydrogen are necessary to react completely with nitrogen. So grams of hydrogen, which we called B, are going to be right here. We're going to end here. All right. So how should we get started? Well, let's start with just writing 50 grams of nitrogen. That's what we have. That's all we know right now. What could we do with this? Okay. So I know the first step to getting to the end is just moving to the closest box to start. We need to go from grams of nitrogen to moles of nitrogen. And in order to do that, I have to divide by the molar mass of nitrogen. Okay, so I'm going to put grams of nitrogen on the bottom of my T-chart so I can cancel that unit. I don't want that anymore. What I want to get are moles of nitrogen. Okay, so let's take a look at the molar mass of nitrogen, and let me look at my handy dandy periodic table to get the molar mass. In 1 atom of nitrogen, the atomic mass is 14. I have 2 atoms here, so 14 plus 14. So the molar mass is 28 grams of nitrogen in each mole. If you need a review on how to find this, I will also post a video to remind you. Okay, so these will cancel. Anything divided by itself is 1. That goes away. Now I have moles of nitrogen. Let's look. Is that where I wrote end? No, I don't have all the info I need yet. I need to go from moles of nitrogen to moles of hydrogen. To do that, you divide by the mole-to-mole ratio. Okay, if I want to get rid of moles of nitrogen, I put that on the bottom, and I want moles of hydrogen. The handy dandy tool I want to use to find the mole-to-mole ratio is our balanced chemical equation. So there's 1 mole of nitrogen, and for every 1 mole of nitrogen, there's 3 moles of hydrogen. Okay, did I get my grams of hydrogen yet? Nope, I only have moles of hydrogen, so I need to go one more step. Right now, I'm at moles of hydrogen. In order to get from moles to grams, and therefore our end answer, I need to multiply by the molar mass of the product. So let's take a look. So I know I want to get rid of moles of hydrogen and end with grams of hydrogen, which is just multiplying by the molar mass. So look at your handy dandy periodic table. In 1 atom of hydrogen, the atomic mass is 1. I have 2 atoms, 1 plus 1. The molar mass is 2 grams for every mole of hydrogen. These will also cancel. Now I have the unit that I want at the end, how many grams of hydrogen. Now I can just do the simple math. 50 times 1 times 3 times 2. That's going to give us 300 grams of hydrogen, but we're not done yet because we got to also check out the bottom. 28 times 1 times 1. 28. And my handy dandy calculator lets me know that that's final answer is about 10.7 grams of hydrogen. As long as you're close to 10.7, you got 10.8, you got 10.6, I'm okay with your answer. Thank you for watching.